Great. So the goal for this initial little session was to do an introduction to cloud computing, really sort of cover the basics of cloud, what it is, what it means, and specifically, I really wanted to go through the National Institutes of Standard and Technology cloud model because I think that really gives everybody a good solid basis for understanding cloud. So the first thing is we want to define clouds, and we can say, well, we know what clouds are. Here are a set of different clouds, and this is a taxonomy that meteorologists use to describe clouds. Well, of course, we're not talking about this class of cloud. We're talking about a different technology for cloud. But in much the same way, I think it's good for us to have a taxonomy, a way of describing what clouds are, how they look, and how they sort of fit together to make this a meaningful discussion. So I usually like to ask, what does cloud mean to you? How would you go about describing cloud? Because that's one of the tools that we use to figure out what a cloud is. And here, of course, we're talking about a data center cloud or an IT-derived cloud, cloud in the computing sense. But still, the cloud definition is how you end up defining it. Well, like I said, the real thing that I wanted to talk about and that I thought would be useful to everybody was to talk about cloud from the National Institutes of Standard and Technology model. So NIST, for those of you that aren't in the U.S., is the U.S. National Institutes of Standard and Technology. They're basically a government body that's intention and their reason for being is to define things. So along the way, as this concept of cloud became important, the community reached out, the government community reached out and said, hey, look, we need a decent model for this, a way to describe this so that we're all talking about the same thing. Much like meteorologists have ways of talking about cumulonimbus and stratus and cirrostratus clouds, we wanted the same sort of thing for our data center cloud technologies. And they came up with this model that said, well, there are really sort of three main domains that we can talk about. And with those domains, we can break it down into a couple of key characteristics. So we start out with the essential characteristics: measured service, elasticity, on-demand, broad network access, and resource pooling. Those characteristics can be used to define a cloud. And once we have those characteristics, we can start talking about service models, another way of describing clouds. Are we talking about software services? Are we talking about platform tools? Or are we talking about infrastructure? And then lastly, there are the deployment models, or effectively, the way I like to think about it, how do you consume these resources? Is there a question? All right. So with that, if we sort of dive a little deeper, let's talk about these essential characteristics, because this is, I think, really what defines cloud in these models. Firstly, we have things like measured service. If we have a cloud, if we have a set of resources, we need to be able to measure them. And the measurement is sort of a basis for describing how much of something has been used. It turns out that measuring service is one of the things that we need to do in order to provide an on-demand service. How much do we have? How much have we consumed? How much is still available for use? Is a very important characteristic of defining something as a cloud. Otherwise, it's just a set of static resources that we don't necessarily get the flexibility, the on-demand aspect of. In fact, I think actually I should probably start with on-demand self-service as really sort of the initial essential characteristic. I consider this actually the base characteristic because much like I can say I can measure something, but just measuring it doesn't mean that it becomes cloud. What really defines cloud to me is this concept of on-demand and self-service. We've had IT for a long time. We've had automated IT even for a long time. We've even had automated IT against virtual environments for, well, that matters, for a very long time. But the concept of an on-demand service, something that I can just request and immediately get that service, is the real big shift. This is the crux of cloud today, at least IT-driven cloud. And so for me to do this, I need to be able to measure it. I also need elasticity. If it's going to be on demand, I have to be able to request it and get it. That's one aspect of elastic, right? But if we think about a rubber band or an elastic band, if I stretch it and I let it go, it returns to its original shape. And this is the other half of elasticity. I think this is actually for some people, especially for people that think of of IT as a service that gets consumed and not released, this is probably the biggest negative in terms of defining cloud and cloud service. Elasticity goes both ways. We want to be able to expand our resource, but we also want to return it back to a pool. And a pool is then the thing that we're expanding and contracting from. If we have a pool of resources, a pool of computers, a pool of disks to consume storage from, a pool of network bits, basically, how much bandwidth do we have available? Can we share that resource? This resource pooling is a very important aspect to cloud and cloud definitions. Right? But all of these things, being able to elastically create and release resources, being able to get a pool of resources that we can now share much more efficiently because we can release and return those resources, all of this is useless if we don't have access to it. And from an IT perspective, that means broad network access. Now, the NIST model doesn't specifically call out network access as something that provides internet access, global internet access to everybody. What they describe is broad network access for the resource group. So when we talk about public and private, we can talk about broad network access within a private domain. So within in an enterprise, or from the government perspective, even within a security context, they actually talk a lot about secret and top secret being separate security entities that could have different network access requirements, but still I can get access to these resources from where I am located, basically enabling this on-demand and self-service aspect rather than where somebody else is located. So we take all these essential characteristics together. I can measure the service so I know how much I've consumed. The other key thing about measuring the service, especially from the perspective of cloud, is once I can measure it, I can also potentially bill for it, or at least show back the information of how much has been consumed and potentially how much has been released. From the perspective of cloud, I think the only reason cloud works the way it does, for example, an Amazon-based cloud is an example of this, is because you can charge for it. Because it's been shown over and over and over again, and in my many years of running IT systems, I have seen it over and over and over again. If I don't have a way of charging you for it, showing you that the use of a resource actually has a cost to the organization or to the company or even individually, there's a very low likelihood that I will ever return that resource back to the pool. I'll start consuming it, and I'll just continue to consume it until I'm basically out of resource. And only then do we get the request for, hey, can we clean up these resources? Is there anything you can release back? If I don't have a way of measuring that service, I really don't have a cloud. I really don't have a way of forcing a user operation that says, yes, I will release resources because I see that there's a cost to the community for me to use these. So these are the characteristics. This is how you define what is or isn't a cloud. All right? And I find that in many cases it's very easy to use these characteristics to define something as a cloud. A classic example, I've talked to so many companies that have deployed things like VMware tools. And I have no issue with VMware tools, by the way. But in general, when VMware tools are deployed, they're deployed to provide virtualization, which is, from an IT perspective, a way of creating a resource pool. Hey, this is one of my essential characteristics. Probably I even have a way of measuring that service. As an IT vendor, IT user, I have a way of measuring how much of my virtualization has been consumed. And as an IT resource, I can provide elasticity. I can add more or remove from the consumed resources in my virtual domain. And I even have broad network access. So from this perspective, 4 of my characteristics are met by virtualization, just as a general component of my environment. But what we found is that most people that deploy virtual machine environments using the VMware model, unless they own that entire VMware system for themselves, and effectively have created an ultra-private environment, they often don't have on-demand self-service access to those resources. Often they have to make a request to an IT department, sometimes even through something as old school as a faxed document that says, I need more capacity, and that breaks the self-service aspect. So while you certainly can build a cloud with VMware tools, and I'm not trying to say you can't, I've seen so many environments where people say, yes, I have a cloud, I have virtualization. Virtualization does not make a cloud. On-demand self-service with a virtualized backend can make a cloud as long as our essential characteristics are met. So essential characteristics really are a way of describing what is a cloud, what isn't a cloud. And it's part of this taxonomy. Can I describe this in a way that around the world we can have a consistent definition of a cloud and cloud technology? So I think incredibly powerful when we look at it from that perspective. Another model is the service model. Um, Service models, things like SaaS and PaaS and infrastructure as a service, are ways of describing how I'm bundling these resources together. In a sense, what resources am I pooling? What resources am I providing elastically? So with our service models, we look at software as a service, we look at platform as a service, we look at infrastructure as a service. Again, these are models of how am I consuming or managing this pool of resources? What is the resource that I am pooling to build my cloud? I think that the easiest one for most of us to understand, at least from a data center services perspective, to understand is this concept of infrastructure as a service. Infrastructure as a service is what it tries to describe. I'm going to take the data center infrastructure, so my compute systems, my x86 servers is the most common sort of model for this, my storage systems, so my shared network attached disk subsystems, and my network environments and my network components potentially even, and use these components as infrastructure. And I'm going to provide that as a cloud service, which means that I'm going to provide a pool of compute, network, and storage. I'm going to provide a pool of these resources in a elastic fashion, so I can add them and remove them at will. And I'm going to provide access to this via a broad network service. I also am going to enable some form of measurements that I know how much has been consumed. And again, in its best iteration, I will measure that service and provide some form of a bill or model that shows the consumption of the resource relative to potentially one's peers, or actually charge you for that resource so that you have the impetus to release resource when it's not being used. That way we all get to share in that resource domain. So from the infrastructure perspective, it's often straightforward. I count the number of computers I've used. I count the amount of network bandwidth I'm consuming on a consistent basis, or the number of network services like load balancer resources that I'm consuming on a consistent basis. How much storage have I locked up and consumed in my cloud environment? That's infrastructure as a service. So again, from my perspective, the simplest of these to understand. The other one that I think is fairly straightforward to understand is software as a service. In this case, a software package or a software system, classic would be something like a mail application, email application. I think the most widely known worldwide probably at this point is Google Mail or Hotmail, or even Yahoo's mail service. These services are cloud services. I can ask for a resource. I would like a mail account. That's the software resource that I'm consuming, and I can ask for it to scale up and down. I can make some changes to it, and I can also return it back to the pool. I can say, I no longer need this email account. Go ahead and delete it entirely. Most people don't do that to their email accounts, but this is the concept, right? I have the ability to increase or decrease the capacity or capability of my resource and release it entirely. So that's software as a service. Now, more commonly, people are talking about things like enterprise resource management or resource planning, ERP type systems as software services. Another common one would be something like the Salesforce tool sets to provide both customer relationship management or enterprise resource planning capabilities in that software service. There's the entire Google suite of online tools or Zoho tools. There's a whole bunch of these sorts of software as a service capabilities that describe the capabilities of cloud and cloud services. But we're really talking about software. And again, the same things apply. Am I able to measure it? Is it rapidly elastic? In other words, can I ask for it and get it effectively immediately? That's what we think of today in terms of what do we expect from our cloud. Immediate might be a couple of minutes, or maybe worst case even an hour, but it can't be days or weeks or years. That's just against the concept of what I think most people expect from their cloud today. Broad network access, I should be able to get at it from anywhere within a security domain, within a resource management domain, so within my enterprise, for example, or within a security zone within my enterprise. And it's a pooled resource, so if I need more, I should be able to get at it. There are, of course, always going to be some limits to that, but from a software perspective, those limits are often very large and very hard to hit. So software makes sense, infrastructure makes sense, but then there's this one in the middle, and this is, I think, to me, it's the catch-all bucket, platform as a service. Platform is interesting because I've seen it described so many different ways. With the platform as a service option, we talk about platform as a service as something that is a set of components from which you might build a software service. At least that's the way that I've seen it best described. So a classic platform as a service cloud service would be database as a service. So I can build a database on top of an infrastructure as a service play. I can use a database in a software as a service cloud play. But a database as a service is often not useful in and of itself, except for as a piece of a larger platform, something else that you would consume. Now, database as a service turns out to be a very powerful and very meaningful platform component, but often I would tie that together with a web scale service, so potentially a web service or a web server front end with an embedded application. And I might actually deploy that web server and its embedded application on an infrastructure as a service play, but I don't have to manage the entire database other than through the platform capabilities, things like automated backups and maybe automated recovery of my database that the platform enables. So there's a lot of power there. Platform as a service is also the environment where most people now map the container as a service systems model. Now, people talk about containers as a service as effectively an alternative or yet another extension to the infrastructure as a service model as well, but I really see it as a platform environment, because a container as a service offering often includes embedded other resources. So it manages network service, it manages load balancing service, it manages scale up, scale down monitoring for your services as a part of the container services deployment systems model. And that's a powerful platform component. Often that's not the end result or the end component of what you would build. You're going to build something on top of it, much like you would build something on top of infrastructure as a service. In the end, we're looking to provide application environments. But these are the service models. So these are the ways that we can think of services that would be applied on top of a cloud. Now, people talk about X as a service, XaaS. And I think that the service models are sort of expanding, but I think you can still always lump them back into one of these three domains. Is it a software service altogether, an entire packaged component that provides a software function that you use repeatably? Is it a platform component, something that you would build on top of, but is still software? So you could call it software as a service, but maybe it's not as complete a service as something that you would actually then be able to provide an end user as an end component. And lastly, of course, infrastructure as a service. Again, I think this is the one that's most straightforward because we're really talking about those base pieces of resource. And you'll notice that across this entire set of service models and even the essential characteristics, nowhere in here have I actually mentioned virtual. Now, I might have said virtual when I'm talking about these components because it certainly is easier to provide a pool of compute resources by making them virtual. But there's nothing to say that I don't have 100 physical computers, for example, and those are my compute resources, or 100 physical attached disks that I can map into my compute resources. Those could be the resources that I'm pooling. There's actually a benefit to that, and we're seeing more and more cloud deployments that include physical resources as part of the pooled resource environment. So while we don't call out virtual specifically, and actually the NIST model doesn't call out virtual specifically, virtual is actually a service component that is very powerful for building clouds because it allows for more resource, more pooled capabilities, and more shared elasticity. Also, it turns out that often virtual resources are faster to deploy. To deploy a physical server often takes minutes, many minutes to even hours to actually get the entire system deployed and up into a running state. For the most part, I've seen, especially with x86 compute environments, I've seen that the deployment time usually is something on the order of 10 minutes. When I virtualize that and create a virtual compute resource, often my resource deployment time is on the order of a minute or so, if not even less. And with the container model that is becoming prevalent today, we're seeing resource deployment times in the form of seconds, if not even less than a second in certain instances. So we're seeing some very powerful components. The same is true for software platform services. Often these services, especially if they're leveraging either a container model or a running, especially in the software space, a running system that is effectively just creating a new database entity, often the provisioning aspect of that is practically instantaneous. The thing that takes time would be things like billing integration and validation, or potentially if a back-end physical resource has to be provisioned, that physical resource provisioning time is something that takes time. An example there is a service deployments take plenty of time, potentially on the order of hours if you have a very large database that you're deploying that actually has to have some base resource written into the database environment, the database structure. That aspect of the system, the time it takes to write a bit to disk, for example, doesn't change just because we're doing this a different way, building it in a cloud sense. It still is a very consistent function. So we've talked about essential characteristics. We've talked about service models. The last aspect of this is the concept of a deployment model. So in the deployment model, really what we're talking about is how is this cloud accessed? Now, we talk about public and private most commonly, where we say, hey, I might have a public cloud, which would be something like an Amazon or a Rackspace or an IBM SoftLayer or one of many others, and I'm not trying to exclude anybody from this list, but just as a set of examples, these are cloud environments. Often they're focused on infrastructure services, at least in the model that I tend to think about, so the ones that I just named tend to focus on the infrastructure service offerings. But they're starting to encroach from the infrastructure perspective, they're starting to move up the services model stack, providing platform services. And then there's the inverse. There are folks like Salesforce.com, which is a very common CRM or ERP set of tools that also provides the ability to basically use their environment as a platform. In fact, at one point they acquired a company called Database.com that was providing database as a service, so a platform service, at least in the way I've been describing platform, and providing that in a public sense. So a public platform as a service that provides software as a service functions in an ERP or CRM class service environment, or platform services. They don't necessarily provide infrastructure as a service, although I believe they also acquired the Heroku tool, which to me still fits into the platform space. We'll talk about that more if we have time a little bit later. So there's the public model. Effectively, anybody can get access to it. Again, that measuring of service becomes very important because often in the public model, there is absolutely a billing component. You're going to pay for this resource if you're going to use it. And that alone is a very important aspect to making this cloud environment functional. In fact, again, I can pay for it. I can tell you you're going to have to pay for it. And if you can't pay for it, I'm going to take the resource back. I mean, that's the extreme version of this. Within enterprises, it's usually, let me show you what you've consumed. Do you really need that much? Because this is consuming something against the entire enterprise, and we should try to share to make sure that the enterprise stays successful. So the other principal model that people talk about is the private cloud model. Private clouds are kind of interesting, and the private cloud is really something that provides this exact same elasticity, resource pooling, measured service, on-demand service, all these essential characteristics, but in a private sense. And private, at least in the NIST model, was specifically described as having limited access to the ability to make the requests, basically the ability to make these on-demand systems requests. Well, that private